item, which was the tutorial that Samriddhi, Shahil and Naveen were conducting. So I think now Samriddhi will continue with a sample, how to basically run and look at the data about the sample. So Samriddhi, you can go ahead and share your screen.
I already shared the screen.
After that, Naveen will take over.
So, so I think my screen is visible, right? So we left at this part, .in and .local. So what we do now, we already have a sample named Kelvin Helmholtz. So we make another directory named KH, and inside it, we will copy in the similar fashion we already did in the previous session. So it's CP minus R, pencil code, samples, 2D test, and Kelvin Helmholtz to this. Okay, so we already know what is actually start.in. It contains the initial parameters. Run.in it contains runtime parameters. Print.in, it contains what diagnostic output we will need to print during the run. README actually contains the file or the paper which uses this sample. So if we see README, we can see that it is done by Vlad, and the paper is this one. And if we go to SRC, it will contain cparam.local and makefile.local. I already told in the previous session, cparam.local contains the CPU configuration parameters, not the configuration, number of CPUs we need in any direction, and the grid size, like cparam.local, nxgrid, nygrid, nzgrid, and n CPUs. Please remember that n CPUs should be equal to multiplication of n proc x, proc y, and proc z. And nx grid, ny grid, nz grid is the grid grid split of x, y, and z direction. In the makefile, it contains the MPI file is a MPI code or not. If it is MPI, so MPI otherwise it's no MPI The list of modules you need for the code, initial condition, sometimes special condition if needed, and the previous value. So in this makefile, the IO file system is not mentioned. If you remember Johannes' talk, Johannes' presentation, he showed 5 different IO systems in the pencil code. In this case, we will use IO distributive. It is not mentioned in the code, but by default, pencil code choose IO distributive. Okay, so now the main code actually starts how to run the pencil code. So when we run the pencil code, it actually stores the results in a directory. We call it data directory. So by default, data directory is not present. Data directory should be present in the current working directory, not in the SRC. And the process is to mkdir data. It will create a data directory. Since we are using our own personal computer, so making it data is useful. But if the code is large or your simulation model taking too much RAM, it is not ideal way to store that data in your home directory. You have to save your data in a scratch space or the data space. And for that time, you have to soft link your data directly to another location. So the link is ln-s, which means that it is soft link, and the path your destination location space data, DATA. It is also mentioned in the manual if you check. So if you do this thing like ln-s, Okay. It is just like so. So if my scratch space have a folder like KH, so the command looks like ln minus f. It's data space by KH space data. It will create a link called data, which directs to a data space folder KH. We are using a personal computer, so we don't need to do that. But if we run or compile our code now, it will show some error. The reason is this is an MPI code, and we have to say that how many processor will save in which folder. So for this, we have to make at least okay, before that, I will show something. My CPU actually has a dual core. So I have to change my local to n CPUs is equal to 2, not 4. And my is equal to 1, x equal to 2. So 2 into 1 is equal to 2. Now the code will run. But in the data, we don't have any folder specific to the every processor. So Pencil Code needs to build one all-procs file, which is a container for the global processor. And then you have to create the directory called proc number for each processor. Since we are using two processors, we have to make proc 0 and proc 1. We can make it like mkdir 0 or mkdir proc 0 and proc 1. But in HPC or in the large simulation, we have to use millions of code, and it is not possible to create millions of code by hand. Not million, but thousands. So for this, Pencil Code already has a helper script. Those scripts, I told that it is residing the bin directory of the Pencil home. So if we go Pencil home bin, it will show one called PC proc tree. This one PC proc tree. So I will go to this part. CD workdir cage, and I forget to source my code. Okay, so since I use my laptop daily, I make an alias SPC, which actually do the same thing what I saw earlier. Source me.sh. Okay, now if I go to the data directory and call that command pc make proc tree 2, it will create proc 0 and proc 1 for me. Okay, it will create proc 1 and proc 2. I don't know why they will be shown, but it is not for my case, I think. So don't worry, it will actually create all procs, proc 0 and proc 1. Proc 0 and proc 1 created by PC proc tree, but all procs you have to create by your own. Now you have to compile the things. So now if you want to compile, so the commands are written in this case, right? So you have to make a mkdir data, then you have to make all procs folder, and then you have to call that helper script and the number of procs you need according to your code. It will create proc 0, proc 1, and how many proc folder do you need. Now to compile the code, what we'll have to do is to call the helper script PC setup SRC. The script actually do one thing. It calls various other helping scripts which needed to compile your code along with the source codes that resides in SRC. So this PC setup SRC actually links those folders those scripts and the files, not copying those things. This command actually only links the files and the script. So we will do this. I'll make a cursor. So I will do PC setup SRC. So now if we go to SRC, we will see various scripts and files. And if you long list those things, so those are links, not the actual files or scripts. Now ls cparam. Oh, sorry. Okay. Now the cparam.f90 is actually linked in this case. ls minus l. Okay. So now after doing this, you have to compile your code. So then we have to compile your code. There is two processes. One is PC build and one is make. Make is generally if your PC build is not working in your system, but to work with make, you have to adapt another file, and the file name is makefile.src, which resides in your src folder of your working directory. So I will go to the src folder of my working directory and open that file, makefile.src. Okay, so now there are some default. So in this case, there are some default compiler setting. By Linux, it's automatically took the default one. For Mac, sometimes you have to define your own. Sometimes it already took the default compiler settings. But if we go, so if you check this part of my code, so this is actually for my system. So my computer name is Surya, and FC is the name of your Fortran compiler you need. CC is the C compiler. F flags is the Fortran flags for your case. C flags is the C flags for your case. And F flags double is the precision flag for Fortran. To adapt that makefile.src, you have to write it in this way. FC is equal to MPI fort or any other compiler, Fortran compiler you want to use, followed with a hash and bracket with your computer name. So the computer name you can get using uname minus n, which actually gives your computer name. So you have to write it in this process. Otherwise, what happened? Pencil code will not will skip your makefile.src. So you have to mention hash first bracket along with your computer name and first bracket close. Also mention that there is one hash before the start of the line. So I will go to my cage or the working directory. PC setup SRC also creates some CSH and a makefile. So this makefile actually contains your compiling and linking the total build process of our code. So I will use make in this case. If I use make, hope it will compile successfully. Let's see, it takes some time. And one more thing, if you change anything in the cparam.local or makefile.local, you have to compile every time you change any of these one file. But if you change anything like start.in, brand.in or print.in, you don't have to change anything. Don't have to compile anything. For start.in, print.in and brand.in, you don't have to compile. But if you change cparam.local or makefile.local, you have to compile it every time. Sometimes make gives some error. That time do make clean. It will create the previous builds and then run make. It will rebuild your code. So after make, so makefile.src actually contains the compiler flags based on the host name. So Surya in my case is my host name, and compiler flags are FC, FF flags, C flags, CC, and it will create a file called cpadam.inc, which actually contains the auxiliary and the global variables for the setup. It tells you how much storage pencil code needs to save a snapshot. So after compiling the code, oh sorry, I think the code.
Compiling, right?
It's compiling. The computer is. It's compiling, I think.
Yeah, I think it is. We can just.
So we can also see the next slide, what is written in the file. Okay, so this is the running process of the code. Okay. Let's give some time to the compilation process. So this is the compilation time. So not the linking of the actual thing. So it is compilation is going on, and after successful compilation, it will link with the executable, and it will create two executable file inside your SRC called start.x and run.x, as PLG already told in the first session. Yes. So this is actually gives the linking part. It creates start.x as a output file and run.x as a output file. So if we go to CD SRC and check .x files, it will show run.x and start.x. So start.x actually initialize your initial parameter in the domain, and run.x is actually running the code. So going to the working directory, and we have to check the data. It will not create any other files except it. All procs, it will not create anything, or also not any other proc 0 or thing. Okay. Okay, cd proc 1. Okay. So now if we go to the main working the directory and run our start.x, it will create the initial values in the data directory. So we use two codes in this case. So the command to running the code, we have to run mpi run -np2, which gives our mpi wrapper script to run it in two CPUs, and then src/start.x. So if you are using single code, then you don't have to put the mpi run -np2, just put .src start.x, it will run your start.x. Sometimes, but in the HPC, you have to submit a job script, you don't run like this. So just submit start.x, it will initialize your initial parameters, and so that start.x is completed successfully. Now, if we go to the data directory, you will see lots of files. The start.x actually creates in the data directory. So if we go to the all procs, you will see grid.dat. So this grid.dat inside all procs contains the total your domain grid information, not for a particular, but the total grid of your simulation box. Now, if we go to the proc 0 and see, so there are dim.dat, grid.dat, var0, var.dat, and varn.list. So inside proc 0, that grid.dat contains that particular processor grid information, and dim.dat also contains the dimension used by that processor. var0 actually the initial snapshot, and var.dat is same of the var0, but the var.dat is actually changed after every I save. Okay, now we will go back. Oh, so similarly, if we go proc 1, it will also save a similar file, but those files are different. The dim.dat actually contains the dimension for proc 1, not proc 0. Grid.dat is also proc 1, var0 is also for that particular processor's initial snapshot. There are some other files like var_name.dat or so the first thing is dim.dat inside data the directory. It contains the total total dimension of the simulation box. Param.nml contains the list for the starting parameters or the initial parameters. Param2.nml will create after we run.x. I think there are not important files. Now we will go our main working directory and then we can run our run.x similar fashion mpi run -np2 src run.x. It will start our run, so it gives these files 0 for 45. So the reason is if we open our run.in, it shows that nt equal to 50. So it stops at 50, but tmax equal to 1.5. But in this case, our t is equal to 0.15. So it's clear that if nt breaches faster than tmax, then the code will stop. And similarly, for if the code touches tmax, it also stops the code. Now, if we go to the data part, it will create, ct proc is 0. So it will create some var files. So var1 is the snapshot of after a dsnap time, and similarly this. And now var.dat is not equal to var0, but var.dat is equal to var8, since it is the last snapshot. Now we have to change few. And one thing is there is one more file, two more files, which is time series.dat, which actually stores the time series values. This is the diagnostic output what we actually brought in the print.in in our working directory. So these are the time evolution of the diagnostic outputs. And also if we check tsnap.dat, it saves pencil code when the next snapshot we will save. So the next snapshot will be 9 and saves at this time. If we check our if we check our data directory, it will show that we only have up to var8. So if we go cd proc 0, only var8 we have, but not var9, since the code actually stops before the var9 actually saves in our data directory. Okay, so we will delete the time series part and the tsnap part. The reason is that we have to check the full evolution for the Kelvin-Helmholtz thing. And for this, we have to change certain parameters inside of it. So we have to change our NT and maybe also Tmax, depend on our requirement. I think NT is equal to 6,000 will be okay. 6,000. And for Tmax, I think we will give it to 10.0. We don't know what will happen in the brand. We just change those things, brand parameters. Dsnap is okay, isep is okay, I think. And we want to print our diagnostic output at every 5 time steps. But I think in the C param we choose like 32 grid point. I don't think 32 is a good resolution number. We can make it 256. So it takes more time than this, but it will give you a good result.
CPUs is okay, number of CPUs.
Number of CPUs is same because we are using the same computer. And since we changed the cparam local, we can't write it now because pencil code have to build the whole thing for this configuration. Then first we have to make clean. Sometimes you don't have to make clean it. Pencil code says that you changed make file, so building process is proceed, but it is good idea to make clean if anything happens. Now you have to make the things again. It will take similar kind of time, and it will build our start.x and brand.x for those grid resolution. Remember, for cparam.local or makefile.local, if you change anything, you have to remake or recompiling the things. But if you change start.in and brand.in, you don't have to make or building the things. One more thing I mentioned in my slide that, so I already tell you that what is inside that data.date. So these are all already I told. Now one thing is important is deload and stop. So suppose you're running a script and after some time you thought that you forget to change any parameters in start.in or brand.in. Then you can go to the brand script, brand.in, change that parameter, save that script, and make a file called make a file named reload. So what happens, pencil code actually steps after every time steps. These two files is present in your working directory or not. If it checks that reload is present in your working directory, then what happened? Pencil code read your brand.in script and saves in param.nml or param2.nml. On the other hand, sometimes you want to stop your code. You don't need your code to run after that much of time, but your while time is also not reached. So you make another folder that stops, which actually create a stop file. And after next step, the pencil code will stop running the code, but in a corrective way. Corrective way means it will save the last snapshot as bhat.dat. So this actually helps you if you rerun your code, that sample after some time. I think the compilation is still going on. We have to wait for some time.
So in the meanwhile, if there are questions on anything, you can feel free to anyway ask anytime. Johannes has a question.
Yeah, not directly a question, but more like a comment. So you said that you have to set up the proc directories in your data directory with the script PC MK proc tree, but if you're using the PC run script to start your runs, you will have you do not need to set them manually. You have just a data directory, and the PC run script will take care of this. So, which I think this is the PC run command is also the preferred command, as I'm understanding it, to start your pencil code runs.
So we were correct. I already write in the presentation that you can use PC run or start.x and brand.x. So what happened in my case that sometimes PC underscore run will not work sometimes, but I also know that using command make is obsolete now in this case. But what machine I used ago, in that machine PC underscore run gives some errors, but my recent machine gives PC underscore run a success. So we were correct too that PC underscore run also gives result without using that PCMK proc script. And also one thing that you don't have to use the make command always. You can use PC build. PC build actually uses your default compilers and compile your code and also build your code. Thanks, Johannes, for this talk, for this part. I think now the compilation, yes, the compilation is successful. Now you have to run our code again, mpi run np2 src underscore start.x, and it will give an error, I think. Oh no error, it's a good thing then. And give run.x, it takes time actually. Because in our case, it's 6,000 time step or 10 time units. So it takes time. Meantime, if anyone have any questions, or Naveen can share his screen, because it takes time to run the code.
So Samriddhi, Shahil here.
Yes,
So you can show the final output, right? In how this density will evolve at the interface of these two fluids.
I will show it after
the output, but it will take some time. In the meantime, you can show that how density evolves.
Okay. So I actually made those commands to show it directly, but since it takes time, no
For
problem.
small time, you can show it, or
because
you are already sharing your presentation, so they can say it, check it, but you can show the final output.
Okay, so this is the final output with 10 frames per unit time if we show in the VLC. So if you check, this is the density plot, and time is shown in this case, and this density plot evolves with time. So this is the Kelvin Helmholtz you normally read in our textbook using pencil code. I only plot the density. You can also plot the velocity and the entropy in this case. And okay, we can also use another thing to do it.
Okay, there was a question by Kai, Naveen also answered, that how to clean up the data directory when you want to start a fresh run.
Okay, so for fresh run, what I encountered is you only need one file, svnid.dat, which actually restrict your code to restart your code only for start.x. But if you want to rerun your code, not initialize, you don't have to delete it. And if you want to delete your data directory, the good command is rm minus rf data. So it will create all your data directory inside it. There are also some helping scripts which actually stores your next run in a different data directory, and for this we have to create a file called datad.in. And inside of it, you have to give the path of that location where you want to store your next run. There are also some commands like PC new run or PC copy var. In this case, you will copy your snapshot with different location if you want to start from that location and don't want to use your previous snapshot to restart. And PC new run also creates a new run folder. So you have to check those helping scripts. Those helping script is actually inside of your bin. And for the visualization script is in Ideal or in Python or in Mathematical.
Okay, so here is another question by Kai. So he's asking, would that be possible to show us a demo for how to restart a previous job?
Yes, it is possible. Yes.
Okay, so it doesn't mean a failed job. It probably means a job you have stopped and you want to restart.
Okay, so I will show it once it is stopped running. I will restart it after that, because I know that it will stop at 6,000 steps, not in the 10 Tmax. So after 6,000 steps, I will show you how to rerun this script. And then we will also stop it using touch stop. I think this will also give you the stopping demo.
But if you do a Control-C, your data files may be corrupted. If they are big data files, you can also, if your grid, I mean, if your domain size is small, you can just say a Control-C and then you can restart it as well.
Yes, it is also.
You want to interrupt and then you want to start. Otherwise, in a different window, you can just go to a different window and show this touch stop, this kind of thing. So if you go to the same directory where the run is happening, so we'll just demonstrate. Oh, and by the way, it is also possible to change some parameters on the go by doing a touch restart.
Reload.
Reload, sorry, touch reload.
Okay, so this is my working directory, touch stop, which actually stops in the next time step.
But now your files are clean.
Now there is no corrupted snapshots. We can start from
now
this.
You can restart from here.
I think it's
PC run if you use.
Okay. So,
or whatever command you are using. I mean, if you're not using PC run, then don't use.
So mpi run minus np2.
So he is using the full command, but as Johannes said, a lot of these are already hidden in the PC_run helper script.
Yes.
So here we are showing it from the scratch, that what exactly
okay, you can also...
so you can see it is starting from the part it stopped. Right? You can just...
So check the time, it's 143 and it's 145 since our D snap is 0.02. And now you can understand why there are hard number and var.dat. So since pencil code saves each last snapshot in var.dat at every processor, so when you rerun the pencil code actually just read the var.dat and then proceed the time evolution. Pencil code don't have to read the whole capital VAR numbers since the last snapshot is actually stored in the var.dat.
So, you have something else?
No, I don't.
You're done. Okay. So if there are questions.